Then it's all at last.
Okay, so today we'll be talking about AI agents for robotic action. So it's all about robots today and AI. And at the end, we're gonna do our quiz and a recurrent neural network demo. Like I did a demo on convolutional neural networks last time, right? You weren't here, Owen, right?
No, it's not that.
Okay, also, keep in mind, guys, next week is last week, so if you guys can submit your projects, get everything done, use whatever tools you have in hand, I'm not asking, I'm not restricting anything. So if you want to use like ChatGPT or anything to help you out, use it, it's fine. All right, so let's start. So week 5B, AI agents for robotic action. We'll be talking about basics of robotics, agents and models, embedded systems, and the current state of AI robots. Alrighty. So what is robotics? Robotics is the field focused on creating machines, which are the robots, that can perform tasks autonomously or semi-autonomously. So all by themselves or maybe controlled by a human, which is semi-autonomously. These machines are often equipped with sensors, actuators, and AI models that enable them to sense, analyze, and act in the real world. So what's AI's role in robotics? AI provides the intelligence that allows robots to make decisions rather than simply follow pre-programmed instructions. Right? AI enhanced robots can adapt to changing environments, learn from data, and autonomously solve problems, just like humans. We adapt from the environment around us, and we learn as we grow. Robots are the same, with AI embedded, of course. The SPPA model, which is sense, perceive, plan, and act. This is all embedded into these robots and AI in the modern age. So sense, which means robots use the sensors like cameras, lidars to gather data around their surroundings. Also like a heat sensor, light sensor, all kinds of sensors that can detect all these things. And then perceive. AI models help interpret this sensory data. So it comes to perceptions like humans, right? Recognizing objects, to recognize objects in front of them or around them in the environment. Understanding the environment and detecting patterns. Alrighty. And they also can plan, just like humans also. Based on perception, AI decides the best course of action, like choosing the optimal path for a self-driving car. That's an example. And then they can act also. The robot performs actions based on the plan, such as moving, picking up objects, or interacting with humans. So basically, robots can see something, know what it is, interact with the environment around them, have perception, plan something, and in the future they're gonna be able to do a lot more things, of course. Examples of AI-driven robotics would be the Roomba that uses AI to navigate homes and efficiently clean rooms. You guys know those little vacuums that move around the house, right? They're AI-driven and they take pictures of everything around their surrounding the whole time, and use a convolutional neural network to perceive everything around them. Also, the Mars rovers we talked about. AI allows the rovers to make autonomous decisions about where to explore and avoid obstacles to Mars. These are two pictures of robots here. See, this is a humanoid robot. Humanoid because it's in the four-limb shape, looks like a human with the 4 limbs. All right. Also, we will talk basics of robotics first. Have to talk about that first. The definition of PPA, the background and examples. So the SPPA model, like we talked, we're gonna recap on that. Sensing, robots gather data from their surroundings, using a variety of sensors, just like cameras, infrared sensors, ultrasonic sensors, or pressure sensors. This sensory data is the robot's way of interacting and interpreting the environment around it, right? Because all the data comes in from these sensors. Also, they can perceive, like we said. Once the data is collected from the sensors, AI algorithms, which are programmed in the robots, process and interpret this information. For example, a robot may recognize that it's near an obstacle. It could be near a rock, near something, which is an obstacle here. Or that a particular object is in its way, which might be like the car knowing there's something on the road, so it can stop or, turn or get out of danger's way. This is the awareness stage where the robots build an internal representation of the environment around them. That's the perception part. And then plan, the robot uses AI techniques to analyze its perceptions and determine the best course of action, right? So the best course of action, which is like knowing the best route to a destination, like the shortest route or something, right? This stage involves decision-making and strategic thinking, where the robot considers options and chooses actions that will lead towards its goal, right? So it has this ability to plan after perceiving, and then it can act in reaction, right? The robot executes its chosen action using its physical components, the motors, the arms, the wheels, whatever components are physical on the robot. This is the movement or interaction phase, where the robot turns decisions into real-world actions. Another introduction here. With the advancement in AI, robots began to move beyond pre-programmed tasks. The advent of the first autonomous robot in the 60s, like the Stanford Shaky, introduced the concept that the robot could think and make decisions independently, like by itself, without a human interfering. Shaky, for example, could perceive its environment, plan routes, and avoid obstacles. That was the simplest kind of robot in the 60s. Now, modern AI robots, today, robots can be equipped with complex AI algorithms that allow them not to only follow instructions, but also learn from the environment, like we said, adapt to new situations, and improve their behavior over time, just like humans. Modern robots, such as autonomous drones, warehouse robots, and self-driving cars, are capable of operating in dynamic, unpredictable environments, thanks to AI, of course. Like we talked about examples, the Roomba and the Mars rovers, we talked about those examples. Take a look here. You see like Shaky the robot here. It was something they made in the 60s and, be able to act independently. Just like the cars also, this is a self-driving car. It can, see all the environment around it. And no, this is a car in front of it, so it's gonna avoid it or keep its distance from it, right? Like we see here, sensors taking data, perception happens where it perceives the environment around it, and then it does its planning after perceiving what's around it in the environment, and then the controls, go to the motors or actuators in the robot's body to change its motion or perform a specific task. All right. Robotics and AI synergy. There's a really good synergy between robots and AI, of course, because AI is embedded into it. So there's a really good synergy there. AI enabling advanced robotics, real-time decision-making, human-robot collaboration, right? AI enables autonomy. Traditional robots rely on preset instructions, right? Instructions that were preset. But AI allows them to adapt and respond to the environment in real time. AI algorithms such as reinforcement learning help robots learn from experiences and make decisions. We talked about reinforcement learning, right? How the model can get punished or rewarded based on its actions, right? That's reinforcement learning. And also real-time decision making. AI enables robots to make. So, how you doing? AI, we didn't skip a lot, so it's just we talked a little bit about the basics of robotics, right? They can sense, perceive, plan, and act, right? We gave an example like the Roomba vacuums and the Mars rover we talked about last time, right? Robots are able to sense, right? From the sensors, heat sensors, pressure sensors, stuff fixed on the robot, right? And then after sensing, it can perceive. So it has a perception of what's around it in the environment, right? Or if it's heat, or if it's light, or the data coming in from the sensors. And then it can plan, right? It can plan something to do after perceiving, right? And make plans. And it can act accordingly, so make reflections and make decisions, right? So we didn't skip a lot, and we're up here to talking about the synergy between robotics and AI. So like we talked here, traditional, like we said, reinforcement learning, it helps train the robots based on punishment and award, based on its actions, right? Right. Real-time decision-making also is embedded. AI enables robots to make split-second decisions based on senior sensor inputs. So based on the input that's coming in from the sensors on its body. Examples would be self-driving cars. They process the data from the cameras, the LiDAR, and the radar to navigate roads and avoid collisions, right? Just like the self-driving cars. And also, we have the concept of warehouse robots that work in warehouses and factories, right? Adjust their paths based on dynamic factors like obstacles in front of them. Obstacle could be anything solid. It can't pass through, of course, because it's not a ghost, right? And or changing inventories, right? Training robots to do all kinds of manufacturing and warehouse work. And also something called cobotics, which is a new science now. Which is human robot collaboration, having humans and robots work in the same environment, right? AI-powered collaborative robots, which is cobots, work side by side with humans in industries like manufacturing and healthcare. This is already taking place, but it's also gonna be really advanced in the future. Cobots understand and adapt to human commands, providing assistance in tasks such as heavy lifting, right? Assembling parts, or even assisting in surgeries. I showed you guys the Da Vinci surgery robot, right? That's an example of that. So taking a look here, see there's a huge synergy between artificial intelligence and robots. And here the global AI and robotics market is gonna be it's gonna boom into the billions, right? It's expected to reach 146 billion by 2023, which is we passed right now. But this is just to show you guys a statistic. Talking about 2033, right? It's gonna reach really high exponential because right now AI is like the new electricity, right? No one can do without it. It's gonna be the future of everything, and you guys already know that since you're taking this course, right? It's gonna be the future of everything, and it's gonna be like the new electricity, which is the thing all companies and homes and people are not gonna be able to do without, So that's another thing right there. Calling it the new electricity is not, is actually very accurate because imagine a life without electricity, right? Back in the 2000s or something, electricity was a thing, nobody can live without it. But now we're in 2024, no one can live without AI. And it's gonna continue like this, into the future. So we're gonna talk about agents, right? AI and robotics, agents and models. We're talking about agents, autonomous robots, role-based agents, reflex agents, models, and some examples. All right. So an overview of AI agents. An AI agent definition would be an AI agent is a software-based entity Okay, so it's a software-based entity capable of perceiving its environment, doing the perception part, like we said, making decisions based on that perception after knowing what it knows from its environment, and then taking action to achieve specific goals. These agents are crucial in robotics, where decision-making must occur autonomously and in real time, right? Where decision-making is happening now and autonomously without any human interaction or interference. How agents work: AI agents receive data from the sensors, like we said, which are the cameras, touch sensors, with whatever's on the body of the instilled into the robot. Process this information using AI algorithms and models that we already know how they're built now and how they work, and then they act upon it. For example, a robotic vacuum might use its sensor to detect an obstacle, like we said, something solid in front of it, a higher ground, a lower ground, and then make a decision about how to navigate around it. So it can do that planning part and taking the action, right? Types of agents here, talking about autonomous agents. Autonomous means doing everything by itself, no other interference, right? Did you raise your hand? Raise your hand. Oh. These are robots that can operate independently of human input. So they're autonomous, right? No human input is required. They continuously gather data from their surroundings, right? Pictures, heat sensors, light sensors, and use AI to make decisions, right? Autonomous robots like self-driving cars and drones can perform tasks just like navigating complex environments, avoiding obstacles, and responding to real-time conditions without direct human control. Right? An example would be the self-driving car uses an array of sensors, LiDAR, cameras, radar to detect other vehicles around it, pedestrians in front of it, so it doesn't run over someone. And road conditions, it autonomously decides when to accelerate, brake, or steer based on this sensory input. So it takes this input from everything around it, and if there's a pedestrian, it's going to stop. If it's going back and there's something solid behind it, it's going to stop. Because there's sensors all around the car, right? That's for self-driving cars. Same thing goes for robots. It's the same concept. It's all using actuators and motors and solenoids, hydraulic and pneumatic. Okay, so we talked about autonomous agents. We're going to talk about goal-based agents next. These agents have a specific goal, right? That's why they're called goal agents, and use AI algorithms and models to determine the best action to achieve that goal, right? They rely on search and decision-making techniques to explore different options and find the optimal path to success, right? So it's not just random, it's looking for the best solution. That's the goal-based agents. Example would be a warehouse robot tasked with picking and delivering items using a goal-based system. It plans the most efficient route through the warehouse by considering current conditions such as locations, obstacles, and other robots, and dynamically adjusting to changes in real time. So it's happening all in real time. Its goal is to pick up something from here and put it here. It's going to see all the obstacles. It's probably programmed on the mapping of the warehouse, so it knows all that, right? So that's how it works. Also, we have reflex agents. Reflex agents react instantly to the stimulus in front of them. Whatever it's light, it's someone calling them. These are all stimuli, right? High temperature from their environment, without storing or recalling past experiences, right? They're designed for a simple task that doesn't require complex decision making or learning, like basic obstacle avoidance or following pre-programmed path. It's just programmed for this one thing, one specific thing, right? Example would be a robotic arm on an assembly line, like a car assembly line or something. There's going to be robotic arms. They're programmed as a reflex agent, responding immediately to the presence of the part to weld or assemble it. So as soon as the part comes in front of it, the sensor knows there's a part in front of it. It does its simple task, right? It performs these repetitive actions with little need for learning or memory. So it doesn't need to have that memory. It's just like, it's done for this one specific task. So this is reflex agents. So the role of AI models here would be that we've seen and have seen trained. The role of AI models here would be in decision making. AI models such as machine learning and deep learning, which we learned about, they play a crucial role in decision making process of these agents. These models allow robots to move beyond simple pre-programmed responses and engage in complex adaptive behaviors. AI models can recognize patterns, predict outcomes, and improve performance over time. So that's the importance of having these AI models embedded in these robots, right? Learning and optimization, AI models that incorporate machine learning enable robots to learn from their experience and optimize their performance. For example, a robot equipped with a reinforcement learning model, which is punishment and reward, like I said, might begin by making random decisions by gradually improving its strategy over time. So it's learning. It's a constant learning process. By learning from the success and failure of past actions. And then there's ensemble learning. Some robots use multiple AI models. Like we said, the word ensemble incorporates multiple models together. So it can use multiple AI models, which is called ensemble learning, to handle different aspects of their tasks. For instance, one model might be responsible for object recognition, while another model focuses on path planning and navigation, right? Examples of that would, like we said, a self-driving car, it's a classic example here. Using autonomous agents, deep learning models to perceive the environment, process data from the sensors, decide how to navigate, right? Humanoid robots, which is, a lot of companies are working on right now, making humanoid robots. They're robots designed to assist in healthcare, customer service. They integrate multiple AI models for speech recognition, to recognize speech, human speech. They have human interaction, doing physical tasks. They can adjust their actions based on the context they're in, right? So their action and speech is based on the context they're in, such as moving closer to a patient or responding to a verbal request. Warehouse robotics, like we said, robots like those are used in Amazon, for example, in its fulfillment centers. They use AI to autonomously navigate, avoid obstacles, and optimize pick and place tasks to improve operational efficiency. Alrighty. All right. So perception also in robots, like we said, using the sensors, perception, AI and perception sensor fusion, vision and language models. Perception in robotics. Robots rely on AI to make sense of the input, like we said. So getting that perception part, which is very important. AI helps robot interpret complex data streams, enabling more intelligent decision making, right? We have something called sensor fusion, which combines data from multiple types of sensors, like we said, cameras, infrared sensors, ultrasonic sensors, etc., to create a richer understanding of its environment. So the sensor fusion concept here is like having the data coming in from all the sensors and then doing this sensor fusion, and it gets a full perception of its environment, right? Example here, like we said, autonomous cars use the sensor fusion technique to integrate inputs from cameras, the LiDAR and radar, right, to navigate safely. Vision and language models, AI vision, like we said before. Robots equipped with AI-powered cameras can see and recognize objects and people around them, right? No, this is an object. No, this is a person, a human. An example would be an industrial robot identifies parts of the conveyor belt, which is these belts going through machines and taking parts from one place to another. Also, language models, like advanced AI models like GPT, enable robots to understand and generate human language. So understanding any kind of human language using the GPT model. Example would be robots in customer service can converse with customers, providing answers to common questions. Right, so we can take a look here, this. So you can get texture perception, hand gesture perception, body posture perception. They know from body posture, grasping object perception, speech perception, and material perception. What kind of material is in front of them, And we have things like textile structures. They can tell if it's a textile structure, cracks in walls or something, 3D structures, all kinds of structures they can perceive, right? And postures. Getting the fusion models, like we said, taking in temperature, pressure, thermal conductivity, texture, all these sensory inputs, right? And they're fused all together to create this full, picture of perception for the robot. And we can see some of the hardware taking this in, the CPU and GPU, of course. It has speakers, it has actuators, electric motors, hydraulic and pneumatic cylinders, legs and wheels, power source, which is going to be a battery or something, a nuclear battery, let's say, or something. Sensors, fingers, arms, which is the humanoid shape like human limbs, right? Interfaces, USB, Bluetooth, Wi-Fi, Ethernet, microphones. So you guys name it. Robots are going to have all this in the future. And these are all the kinds of sensors that take in that data, like we said, create that perception. Alrighty. AI in robotics innovation. So AI and machine learning they have a profound impact on robotics, right? Revolutionizing robotics, first of all, the integration of artificial intelligence and machine learning transformed robotics, allowing robots to perform complex tasks that were previously thought impossible, right? AI enables robots to learn from experiences, just like humans, adapt to new situations, and improve their performance over time. Enhanced capabilities. So AI and ML made robots with enhanced capabilities. Innovation like advanced perception systems, very advanced perception systems now, allow robots to interpret sensory data in real time, like we said, leading to improved decision-making capabilities. For example, robots can now analyze their surroundings and adjust their actions based on varying conditions, such as avoiding obstacles, we said, and navigating. Healthcare innovations. AI has paved the way for significant advancement in medical robots, surgical robots, like we talked about in AI in medicine, enhancing surgical outcomes and reducing recovery times for patients. These robots can analyze patient data and suggest optimal procedures based on individual needs. Also, diverse applications would be the investment in robotics have led to applications across various sectors, including manufacturing, logistics, agriculture, and even space explorations, like we talked about last time. AI-driven robots can automate processes, perform quality control, undertake dangerous tasks in hazardous environments that humans would rather not come near, working on really high places, really deep places in the ocean, stuff humans, don't want to, that may be dangerous for humans, to interact with. So advantages here of ML and AI integration would be efficiency. Robots can operate continuously without fatigue, like humans. We get fatigued and tired, right? Increasing productivity and efficiency in manufacturing and other industry. They can handle repetitive tasks with greater accuracy than humans, reducing errors and enhancing quality. Safety also, AI-driven robots can perform hazardous tasks, like we said, in the environment, reducing the risk to human workers and the human workforce. For example, bomb disposal robots can safely neutralize explosives, while drones can expand dangerous infrastructure. So instead of letting a human go, and get himself blown up by cutting off the wrong wire or something, send the robot in and it can take care of it, right? Challenges of this would be job displacement. The rise of robotics in the workforce raises concerns about jobs, right? People are going to lose their jobs if robots and AIs are going to be doing everything, which is already happening. They're laying off a lot of jobs because of AI. People are losing their jobs in every field, really. As robots take over repetitive or dangerous jobs, the need for the reskilling and upskilling of the workforce to prepare for futures where humans and robots collaborate. So telling you guys from now, get into AI. whatever your field is, whatever you guys are gonna get into AI, because it's the future of everything now, right? Because people that know AI are replacing people that don't know AI, right? And there's a lot of people losing their jobs for that because of robots and AI. And we don't know like how it's gonna be in the future, but it's already happening, and it's weird. Anyways, ethical considerations here. As robots become more autonomous, ethical questions arise regarding their decision-making capabilities. Issues like accountability in the event of an accident, the use of robots in military applications, and ensuring AI operates with ethical boundaries require careful considerations and regulation. And we'll talk more about the ethical concerns of AI on next Tuesday. All right. So this is edge computing in AI. I don't want to go through this a lot. I'll just show you guys a video because edge computing is like doing computation in real time without having to be connected to the internet, right? So they can do these complex computations without being connected to the source or to a database or something like that. It can happen in real time. I just put this here as an extra one so you guys can read about it a little bit. But I'm going to show you guys a video, like a 5-minute video, that kind of shows how edge computing is advancing in this field. This is called Sarcos. They build like skeleton robots to be able to lift more and make people like superhumans, basically. It's in like an extra skeleton on your body. You know what I'm saying? Carry stuff that's 300 pounds and feel like you're carrying 5 pounds. You guys kind of got the idea, right? AI plus edge computing. It's like edge AI now. It's the future of computing for these robotic techniques. Already. So continued AI and robotics innovations. I'm going to show you another video here showing the interaction between a human and a robot. And embedded AI systems, robots with embedded AI systems can operate autonomously, processing data internally, and reducing the need for external inputs from humans or any other source. An example would be autonomous delivery drones use embedded AI to navigate and avoid obstacles in real time. Flying drones. AI models for robots. Embedded AI models such as machine learning algorithms we talked about provide robots with the ability to learn from experience and optimize their performance over time. An example, like we said, manufacturing robots improve the accuracy of assembly lines through continuous data analysis. Real-time continuous data analysis. And then we have decentralized systems. Decentralization allows robots to communicate and coordinate tasks with other robots, creating flexible and adaptive multi-robot systems. Example would be swarms of drones working together in disaster relief efforts, sharing information to cover larger areas efficiently. So it's a decentralized system. Let's take a look at this video and see how robots and humans. I don't like these. So this is powered by OpenAI, the company that made ChatGPT. See this? This is amazing, right? Like telling it to seeing what it's doing, what it just did while doing something. What do you see in front of you? This is amazing. Like it perceived everything, it responded. Just amazing. Yeah. So it's gonna get much more advanced than this, of course, you know. But we're talking about, you know, advancements in this field. Alrighty, so current state of AI and robotics. AI and machine learning are transforming robotics. AI and machine learning have revolutionized robotics by enabling machines to perform complex autonomous tasks. So we're talking about autonomy, right? Autonomous vehicles that analyze road conditions in real time, talked about. Pros of this would be increased efficiency in industries like manufacturing, healthcare, and agriculture. AI-powered robots can take on repetitive, dangerous, or physically demanding tasks that require, you know, a lot of laboring. Freeing humans for more creative and critical roles, so humans can have time to do more creative and critical stuff, right? Concerns would be about job displacement, like we talked about, due to automation. A lot of people can lose their jobs, you know, due to AI being taking over everything, you know, and you know, being the reliability of everything now. Ethical and safety concerns regarding fully autonomous systems like self-driving cars, military drones. The need for addressing transparency, of course, accountability, and safety in AI-driven robots, because you know, it's a very powerful tool and it needs to be used responsibly. We can see here, you know, AI and machine learning, cobots, you know, working with humans, mobile manipulators, digital twins, and humanoids we have right now. You know, we're making the humanoids just like you guys saw. You know, these humanoids are going to be able to do more sophisticated movements, sophisticated postures, and probably, you know, become just like humans and everything in the future. You know, like you guys see Terminator or iRobot or all these movies. It can get, you know, like that or even more advanced actually. So the future is way ahead of that stuff. So we're talking about medical cobots, for example. Collaborative robots assist the healthcare professionals in patient care tasks, diagnosis and treatment planning. Examples like AI-assisted robots help with patient mobility and rehabilitation centers, right? Surgical robots, like we talked about, the Da Vinci surgical system allows surgeons to perform delicate operations with higher accuracy. We saw the Da Vinci system in a video in work, right? In action. Strategic uses of AI. They also allow AI allows medical robots to analyze large data sets like patient records to provide personalized treatment recommendations for personalized people. Example would be AI-powered diagnostic tools. They help doctors detect disease like cancers at early stage by analyzing medical imaging. We did the cancer data set before and showed you guys a little bit on that. Let's see this video also, how AI is pushing the medical industry. Let's hope there's not an ad here. It's symbiotic. Let's see Spider-Man 3, where the symbiote got over him, became that black Spider-Man. This is that symbiotic feeling where the human and the robot are totally like in sync with each other, right? Something like that. It's amazing, right? Especially that symbiotic part where you know the robot and the human become totally in sync with each other, right? It's amazing. The last video here I'm going to show you guys before we start our recurrent neural network demo. This video shows how human, you know, robots are going to become in human likeness. This is the last video, I promise you guys. We're going to see this, and then I'm going to show you guys a recurrent neural network demo. Let's see this. It's amazing, right? Like, they're gonna make robots in the future that can probably have feelings like humans, and probably make them humans. It's crazy, right? But like they said, it's exciting, and the future ahead is not gonna stop at one thing, right? You guys see that Sophia robot? Anyone see it? Where it had like face features, and it's able to smile, it's able to talk, it's able to do all these things, right? That's crazy, right? I mean, in the future, it's gonna advance far more than that. I'm saying by 2030, it's like we can go buy a robot for like $15,000 or something that can go do your groceries and drive your car and do all kinds of good stuff. Alrighty, so guys, I'm going to show you guys a quick demo on a recurrent neural network. We saw a convolutional neural network last time, right? So we know convolutional neural networks work with best with images and video, graphic information, graphic data, right? Recurrent neural networks, like we said, work better with sequence data, like text here, because they're written in a sequence data, like phrases and text and speech, human speech, because it's all in a sequence, put in a sequence, grammar, all this good stuff. Recurrent neural networks, they thrive at that, right? That's what they do best. So here I made a data set because I couldn't find one. To train sentiment. Sentiment is like what you think about something, right? I have 5 sentiment classifications here, which are very positive, from negative, very negative, neutral, positive, and very positive. So, like if I say I find I'm trying to train it to see if comments online and reviews of people. I'm training it on comments and reviews. So I absolutely love this product. This is a very positive one. This is the best experience I've had. Very positive. It's okay. Not great, but not terrible. Neutral, right? I'm not satisfied with this service. Negative. So I make the data set on this, in this fashion, right? I put here 60 sentiments and in one array, and in the second array, I have each sentiment and its each phrase and its sentiment. So very positive, very positive. So first two here, very positive, very positive. So I have 2 arrays, 60 and 60, right? We run this here. I put them in a data frame first, like we always do. So it put it for me in a data frame. I have 60 comments and 60 sentiments, right? So that's what I'm training my recurrent neural network on. So I'm going to import some libraries, especially the LSTM, which is a type of recurrent neural network we talked about, the long short-term memory. And then there's gated recurrent neurons, and then there's other recurrent neural networks. Then I map the sentiments from numbers to names here. At 0, we have very negative. At 1, we have negative. At 2, we have neutral. At 3, we have positive. At 4, we have very positive. So I align my data frame to that, run this, and I have so I put it here. So like here, the data frame, I absolutely love this product. It's 4, so it's a very positive. This is the best experience I've had. 4, very positive. It's okay, neutral. That's at 2. So then we take a look at the count, see which one is the most in this data set. It shows me here that the very positive has the most. Just to get like an idea about how the data is distributed. So very positive has the most sentiments here. Do our data pre-processing. Max number of words that can be tokenized is 8,000. The maximum length of a word is 100 characters, right? These are hyperparameters I can go back and change if I want to, right, later, if the model doesn't do good. I use 10% of the data on testing. We're doing the training test split, right? So 90% is used for training. Let's run this. And then we come to training the model. It's using a 64 layers. It's a LSTM I chose instead of like a a GRU, a gated recurrent neuron or something. We can use any other type of RNN. You just have to import it, like we did up there. Our activation here is ReLU, and our output activation is softmax, right? These are also hyperparameters we can do. Dropout, like we said, we talked about neuron dropout before, right? We can drop out some of the neurons to do some normalizing. So I'm dropping out 0.2, which is 20% of the neurons, making a little bit of an adjustment here. Optimizer, I chose Atom, right? The metric accuracy, categorical cross entropy, right? These are all things we talked about. And now I'm showing it to you in action. I'm using 70 epochs, which is going to iterate through the data 70 times in 45 batches. Instead of going in one time, we put it in 45 batches. Then 30% for validation. So I split it first into training and testing, and then I'm adding the validation here, and we're gonna run our 70 epochs here and see how accurate it's gonna be. So it's running the epochs, as you guys can see here. See? I'm at epoch 30 now. Accuracy is increasing, as you guys can see, after each epoch, 80%, 90%, right? Hopefully we can get 100%. Okay, so 70 epochs, and I gained 100% accuracy out of running it with 70 epochs. I can always go back and adjust these things to get higher accuracy, but this is the best I could get on this one, which is 100% is good, of course, but on the cross-validation accuracy, it didn't do that good. So there's a little bit of an overfitting, remember? Overfitting and underfitting. So it didn't do that well on the validation accuracy, that you can see here. So there's overfitting, so we have to go back and do some tuning, which is, I don't have time for that right now, but it's just to show you guys the idea. Make a confusion matrix to see how the classification did. It has some wrong ones here. It was a very positive and it made it a neutral. There's a couple that are very positive and it got it very positive. But it shows us here the confusion matrix on the distribution. Then we're going to see the training history curve. We can see here that the training accuracy, which is in blue, is increasing as epochs go forward. And our loss on our validation accuracy didn't do that good, which means there's a little bit of an overfitting, as we can see, right? And then we'll see the loss. We can see that loss is decreasing as epochs go, and up here accuracy is increasing, right? Which is a good thing. But also this validation problem we have to fix, by doing some tuning, like we said before, because there's a little bit of an overfitting, but it's just for a demonstration here. Then we can see all four of them in one graph. Like I said, training, the accuracy is going up and the loss is going down, which is what we want. So I'm testing it here on 10 different comments to see what the sentiment is going to be. So I run this cell and then make my analysis here. So this product is amazing. It predicted as positive, which is good. It's did good. I'm not happy with my purchase. It predicted as positive while it's supposed to be negative. So this is one bad one. Shows us, it did a little bit on the accuracy. It's an okay product, nothing special. Put it as neutral, which is good, right? Worst experience ever, very negative. That's a good classification. Decent quality for the price, very positive. I absolutely love it. Not worth the money, neutral. Average performance, I would have said this was a neutral, but it classified it as a negative. Exceeded all my expectations, very positive. I'm returning this immediately. So I have two bad ones here. I'm returning this immediately. It's supposed to tell me very negative. And this one is supposed to tell me a negative also. So it's doing pretty good. We can do some training and fixing stuff. So to show the labels, predicted this as a positive, this is a positive, right? I printed out the colors here of them to show you guys that the very negative is at the red, the very positive is at the green. Show our learning curves, right? See, this is from the learning curve here, knowing that the accuracy is going up, loss is going down, but the validation is not doing that good. So there's a little bit of an overfitting, like we said, we can adjust some things. And the rest of it is, regular stuff. So this shows you an idea of how a recurrent neural network works, right? I showed you guys how the pictures go into a convolutional neural network. We trained it on the 10 pictures. It predicted it all right instead of one. Here we have 2 wrong ones from the confusion matrix. But this shows you how it's done, right? How this sentiment is done, right? Like this is a sentiment analyzer model, which I can, 60 lines of data is not enough to train something like this. I need like at least like 50,000 comments and reviews to train it pretty well. I'm just showing you guys a demonstration of how this works, right? So do you guys get the idea? You get the idea of the convolutional neural network? This is the recurrent neural network. And just to let you guys know, like I said, this could have taken a very long time to train, but with the hardware and the fast internet we have now, I trained it for you guys in like 5 minutes, right? Didn't take anything. So I'm gonna put all the demonstrations and demos for you guys in your student resource to take a look at these notebooks and learn from them. And right now, it's time for you guys' quiz, so I'll open it up for you. And so we can do the quiz. Is it open? You guys see it? I'm gonna check. Open?
Yeah.
All right, take it, and when we finish, we'll